Here's a home improvement project that costs about $8 for materials. Takes roughly 45 minutes to complete, requires zero tools beyond a utility knife, and saves typical American homeowners $80 to $120 annually on water heating costs for decades. We're talking about pipe insulation sleeves. Those simple foam tubes that slip over hot water pipes in basements, utility rooms, and crawl spaces. They reduce standby heat loss from hot water plumbing by 60 to 80%, delivering hot water faster to fixtures, reducing water waste while waiting for hot water to arrive, and cutting water heating energy consumption substantially. The payback period typically runs 1 to 2 months, producing extraordinary returns that few other home improvements can match. Most homeowners have never considered this improvement because the pipes are hidden in basements or utility spaces where they're out of sight and out of mind. Yet these hidden pipes represent one of the weakest points in typical water heating system efficiency, silently losing heat to surrounding air throughout every minute of every day. The problem intensifies at fixtures most distant from water heaters, where hot water must travel through substantial piping runs that dissipate heat along the way before reaching users. Understanding why pipe insulation works so effectively, how to install it properly, and what benefits homeowners can realistically expect helps capture substantial savings that most American households are currently leaving on the table through simple oversight. The basic physics of pipe heat loss involves thermal transfer from hot water through pipe walls to surrounding air. Bare copper pipes at 120 degrees lose roughly 30 to 50 BTU per hour per foot to 60-degree basement air, depending on pipe diameter, air movement, and specific conditions. Multiplied across typical 50 to 150-foot total hot water pipe runs in average homes. This represents continuous heat loss of 1,500 to 7,500 BTU per hour, whenever hot water is available at fixtures. The continuous losses require water heater operation to maintain tank temperature, driving up energy consumption even when no one is actively using hot water. Pipe insulation reduces these losses dramatically by adding thermal resistance between hot pipe surfaces and surrounding air, slowing heat flow to a small fraction of uninsulated conditions. The foam insulation sleeves typically used for pipe insulation provide R values of R3 to R5 depending on wall thickness and foam type. These values reduce heat loss by factors of 4 to 8 compared to bare pipes, producing the 60 to 80% loss reductions that typical installations achieve. The reduced losses both save heating energy and reduce the wait time for hot water to arrive at distant fixtures. Shorter wait times reduce the volume of cool water that users run down drains while waiting for hot water, producing additional water savings alongside the energy savings. The sleeve materials come in several varieties addressing different applications and budgets. Closed-cell polyethylene foam sleeves represent the most common choice, offering good thermal performance, moisture resistance, and easy installation at low cost. Elastomeric rubber sleeves provide similar performance with different handling characteristics. Fiberglass pipe insulation offers higher performance, but requires more complex installation. Reflective foil insulation addresses specialized applications involving extreme temperatures. For most residential applications, standard polyethylene foam sleeves provide optimal value combining adequate performance with minimal cost and simple installation. Terrence Wolcott, a home efficiency consultant based in Cleveland who has personally installed pipe insulation in over 1,100 homes, has documented performance improvements from his projects over 22 years of practice. His tracked data shows average annual water heating cost reductions of 8 to 14% from comprehensive pipe insulation installation, with specific savings varying based on pipe run lengths, water use patterns, and baseline conditions. The installation time for comprehensive projects typically runs 1 to 3 hours. For average homes, requiring only utility knife and scissors for sleeve cutting plus duct tape for joint sealing. The minimal time investment combined with substantial savings produces hourly, effective returns exceeding $200 per hour of installation work. The specific pipes that warrant insulation include all exposed hot water supply pipes, and the first 3 to 6 feet of cold water pipes connected to the water heater inlet. The hot water lines lose heat continuously throughout their lengths, making insulation valuable across all exposed runs. The cold water lines near water heaters can experience heat transfer from adjacent hot water lines through thermal bridging and natural convection effects, with insulation preventing this unwanted heat loss. Insulating additional cold water pipes beyond the water heater area typically provides minimal benefit. For residential applications, though condensation prevention on cold pipes in humid environments may motivate more extensive cold line insulation. The installation process for pipe insulation sleeves proceeds straightforwardly for accessible pipes. Sleeves come in 6-foot lengths, with slits along their lengths for installation over existing pipes. Users open the slits, position sleeves around pipes, and press the slits closed. Joints between consecutive sleeves and turns require tape sealing to prevent air gaps that would compromise performance. Pipe elbows, T's, and valves require cut-and-fit sleeve pieces to maintain continuous insulation coverage. Complete systematic coverage across all exposed hot water pipes maximizes the benefits available from the insulation investment. Yolanda Ferreira Santos, a plumbing contractor operating in the Phoenix metropolitan area, has made pipe insulation a standard offering alongside other water system services. Her client tracking shows that retrofit pipe insulation projects consistently produce client satisfaction through multiple benefits, including reduced water waste, faster hot water delivery at fixtures, and lower utility bills. The combination of benefits exceeds what any single measure could provide, making pipe insulation recommendations an easy addition to almost every water system service call. The practice patterns demonstrate how pipe insulation fits naturally into broader water system maintenance and improvement work. The water savings component of pipe insulation benefits deserves attention alongside the energy savings. Uninsulated hot water pipes allow hot water to cool substantially between uses, requiring users to run cool water down drains while waiting for fresh hot water to arrive from water heaters. This wait time water waste accumulates across hundreds of daily fixture uses in typical households, adding up to thousands of gallons of wasted water annually. Pipe insulation keeps pipes warmer between uses, reducing wait times and the associated water waste. Households with long pipe runs or infrequent hot water use patterns see particularly substantial water savings alongside the energy benefits. Now for the obstacles and limitations that affect pipe insulation applications. First, the accessibility challenges in some homes prevent straightforward insulation installation. Pipes buried within walls, ceilings, or floor assemblies cannot receive sleeve installation without opening those finishes. Pipes in tight crawl spaces may be physically difficult to access for insulation installation, even when they're technically visible. Pipes behind UVAC equipment or water heaters may require equipment relocation for access. These accessibility limitations reduce the practical scope of pipe insulation to readily accessible runs in basements, utility rooms, and similar spaces, though these typically represent substantial portions of total hot water piping. Second, the pipe diameter variations complicate sleeve specification. Residential plumbing includes pipes ranging from 1/2 inch to 1 to 1/4 inch diameter for different applications, with each diameter requiring appropriately sized sleeves. Mixed pipe sizes in a single project require multiple sleeve sizes to match different runs. Inventory of correct sizes at local hardware stores varies, sometimes requiring multiple store visits or special orders to obtain complete material sets. The complications don't prevent successful projects, but require slightly more planning than the apparent simplicity of the improvement might suggest. Third, the sleeve joint sealing requires attention for optimal performance. Gaps at sleeve joints, elbows, T's, and terminations allow heat loss through exposed pipe areas that bypass the surrounding insulation. Incomplete sealing at these locations can reduce performance substantially compared to thoroughly sealed installations. Taking the additional time to properly tape all joints and fit sleeve pieces around fittings produces meaningfully better performance than quick basic installations that leave gaps throughout the system. Fourth, the sleeve thickness limitations in standard products restrict maximum available performance. Standard residential polyethylene sleeves typically provide 1/2 inch to 3/4 inch wall thickness, which delivers adequate performance for typical applications but doesn't maximize what's technically achievable. Thicker sleeves delivering greater thermal performance are available, but at higher cost and with installation challenges that standard sleeves avoid. For most residential applications, the standard options provide good value without justifying the complications of thicker alternatives. Fifth, the aesthetic limitations in visible pipe locations may affect acceptance in finished spaces. Foam sleeves in attractive basements, utility rooms, or exposed pipe installations in finished areas may affect visual character in ways some homeowners find objectionable. Solutions include painting sleeve surfaces to match surrounding decor, installing sleeves only on hidden portions of pipe runs, or selecting less visually prominent elastomeric alternatives to foam sleeves. The aesthetic considerations matter primarily for pipe installations in finished visible spaces rather than typical basement or utility room applications. Despite these considerations, pipe insulation represents among the simplest, most cost-effective home improvements available. The combination of minimal materials cost, quick installation time, no tools required beyond utility knife, and immediate substantial savings makes pipe insulation attractive for virtually every homeowner with accessible hot water pipes. The specific numerical example for a typical home helps illustrate the economic case. A home with approximately 80 feet of exposed hot water pipes in a basement needs roughly 14 sleeve pieces, at 60 cents each, totaling approximately $8.40 for materials. Installation time of about 45 minutes represents minimal opportunity cost for most homeowners. Annual energy savings of roughly $96 based on typical water heating costs, and 10 to 12% savings from comprehensive insulation produce payback in just over 1 month. The continued savings across the indefinite useful life of the insulation, effectively matching the useful life of the pipes themselves, accumulate substantial returns. The simple math makes pipe insulation essentially a no-brainer for any homeowner with basic ability to use a utility knife. Gustavo Arellano Vega, a utility program coordinator who has managed residential water heating efficiency programs across Texas and Oklahoma, has documented how pipe insulation contributes to overall water heating system efficiency across diverse residential applications. His program data shows that pipe insulation as part of comprehensive water heating improvements consistently produces reliable savings with minimal implementation complexity. The measure's simplicity and reliable performance make it a standard component of utility efficiency programs seeking cost-effective interventions across broad customer populations. The program experience validates pipe insulation as among the most universally applicable water heating efficiency measures available. The comparison between pipe insulation and other water heating improvements illuminates the exceptional value proposition. Water heater replacement typically costs $1,000 to $3,000, while reducing water heating energy by 10 to 25%. Tankless water heater installations cost $2,500 to $5,000, while reducing water heating energy by 15 to 30%. Solar water heating systems cost $4,000 to $8,000 while reducing water heating energy by 50 to 80%. Pipe insulation at $8 material cost producing 8 to 14% energy savings dramatically outperforms these alternatives on cost-effectiveness metrics. The measure represents the obvious starting point for water heating improvement sequences, with its near-zero cost making it essentially risk-free regardless of subsequent improvements planned. The broader environmental implications of widespread pipe insulation adoption would be substantial despite the individual measure's modest scope. If all American homes with accessible hot water pipes received basic insulation, national water heating energy consumption would decrease by an estimated 3 to 5%, representing meaningful carbon emission reductions at aggregate scales. The environmental benefits per dollar invested would be extraordinary given the minimal material costs involved. Utility efficiency programs and government incentive programs increasingly recognize pipe insulation as a fundamental building block in residential efficiency strategies. The typical DIY approach to pipe insulation suits homeowners comfortable with basic home improvement projects but lacks formal training requirements. Online resources provide comprehensive installation guidance through videos and written instructions covering typical residential applications. Materials are readily available at every home improvement store nationwide. The minimal tool requirements include only utility knife, measuring tape, and duct tape for joint sealing. The accessible nature of the project makes it suitable for virtually any motivated homeowner willing to spend an hour on basement work. Miriam Obaseki, a home improvement educator who teaches community workshops on energy efficiency fundamentals, has documented that pipe insulation workshops consistently produce participant success rates above 90% for completing the projects at participants' own homes within a month of attendance. The measure's accessibility and clear benefits make it an ideal starting point for homeowners beginning efficiency improvement journeys. The successful completion experiences build confidence for tackling more substantial improvements subsequently. The workshop patterns demonstrate how pipe insulation serves as an effective entry point into broader home efficiency awareness and action. The long-term durability of installed pipe insulation matches or exceeds the useful life of the plumbing it protects. Properly installed foam sleeves remain effective across decades of service without degradation, replacement needs, or maintenance attention. Elastomeric sleeves provide similar durability with slightly different aging characteristics. Properly taped joints maintain their seal integrity across long periods provided the tape remains suitable. The durability characteristics spread the already minimal initial investment across very long operational periods, producing lifetime savings that dwarf the trivial initial costs involved. The interaction between pipe insulation and overall water heating system performance produces compounding benefits worth understanding. Pipe insulation reduces the heat losses that drive water heater cycling frequency, allowing water heaters to operate less often between heat-up cycles. The reduced cycling extends water heater lifespans by reducing thermal stress on tanks and heating elements. The combined effects of reduced energy consumption and extended equipment life produce lifetime savings that exceed simple annual cost calculations suggest. Household situations where water heaters approach end-of-life conditions benefit particularly from pipe insulation, which can defer replacement needs through reduced equipment stress. The regional performance variations in pipe insulation benefits reflect climate conditions and basement temperature patterns. Northern climates with consistently cold basements in winter produce larger hot water pipe heat losses that insulation addresses, producing larger percentage savings from insulation improvements. Southern climates with warmer basements produce smaller baseline losses and correspondingly smaller insulation benefits. Mixed climates between these extremes produce intermediate benefits. The regional variations don't eliminate the benefit of pipe insulation anywhere but explain why northern installations typically show larger percentage savings than southern installations. Gabriella Thompson Miller, an energy auditor specializing in Vermont and New Hampshire residential properties, has documented particularly substantial savings from pipe insulation in cold climate applications. Her measured results from over 400 homes show annual water heating cost reductions of 12 to 18% from comprehensive pipe insulation in northern basement conditions. The larger percentage savings reflect the greater temperature differential between hot pipes and cold basements compared to warmer climate conditions. The auditing experience validates that pipe insulation deserves particular priority in cold climate applications while remaining worthwhile in all conditions. The homeowner satisfaction patterns with pipe insulation improvements consistently exceed expectations regardless of their modest scope. Homeowners who install pipe insulation often describe the project as among their most satisfying home improvements through the combination of simple installation experience, immediate noticeable benefits at fixtures, and ongoing utility cost reductions. The satisfaction often motivates additional efficiency improvements as homeowners experience firsthand how simple measures can produce meaningful results. The positive experience patterns make pipe insulation an effective gateway to broader home efficiency engagement. Consider what comprehensive pipe insulation represents for typical American households. An $8 material investment produces $80 to $120 annual savings that continue indefinitely across the useful life of the plumbing system. The payback period of roughly 1 month makes the economic case overwhelming. The installation requires only basic utility knife skills accessible to any motivated homeowner. The work proceeds comfortably during a single relaxed afternoon. The benefits include faster hot water at fixtures, reduced water waste while waiting for hot water, and lower utility bills. The environmental contributions accumulate at both household and aggregate scales. The improvements are invisible in daily use but deliver continuous benefits quietly. The approach works for virtually every home with accessible hot water pipes, which represents the vast majority of American residential buildings. The question isn't whether pipe insulation provides substantial benefits. The question is why so many American homeowners continue leaving this easy money on the table through simple unawareness or inertia. The answer typically involves awareness gaps rather than any genuine obstacle to successful implementation. For any homeowner reading this who has not yet insulated accessible hot water pipes, a trip to the hardware store this weekend, combined with an hour of basement work, will capture savings that continue paying back every day for decades to come. Few home improvements offer returns this favorable through effort this minimal. The complementary measures that pair naturally with pipe insulation include water heater tank insulation blankets for older water heaters, lacking adequate built-in insulation, low-flow fixture upgrades that reduce hot water consumption volumes, and water heater temperature adjustments that balance hot water availability against standby losses. Each of these measures individually produces modest savings, but combined they can reduce water heating costs by 20 to 35% compared to unimproved baselines. The measures complement each other without interference, allowing homeowners to pursue comprehensive improvements through sequential small projects that spread investment and effort across manageable increments. Ronan Blackwood, a sustainable housing advocate who has organized community weatherization projects across rural Oregon, has documented how simple measures like pipe insulation introduced through community programs reach households that commercial efficiency services would not otherwise engage. His volunteer-based programs install pipe insulation alongside other basic measures at no cost to qualifying low-income households, producing substantial utility cost reductions for families struggling with energy affordability. The community approach delivers the measure's benefits broadly across populations that would otherwise lack access to efficiency improvements. The advocacy patterns demonstrate how accessible efficiency measures can address affordability alongside environmental concerns simultaneously. The homeowner psychology around simple efficiency measures involves factors worth considering for broader adoption efforts. Many homeowners assume that meaningful efficiency improvements require substantial investments and complex technical decisions, missing the accessible starting points like pipe insulation that require neither. Educating homeowners about accessible measures creates awareness that unlocks adoption potential. Positive experiences with simple measures build confidence for tackling more substantial improvements. The progression from simple to complex measures often produces more comprehensive results than approaches that start with large projects. Understanding this psychological pattern helps frame how homeowners approach efficiency improvements and how programs can effectively support adoption across diverse household situations with varying resources and expertise levels.